Students, today we will be discussing about the medicinal chemistry, the third year for the 5 comparative drug design or quantitative structure activity relationship. So here we will be presenting the just follow. So I think the screen is visible to everyone. Okay. So now we should know the structure, quantitative structure activity relationship. So according to the medicinal chemistry, we are dealing with the structures of different chemical. So according to the structure, there are different substituents and different functional group and they have a particular pharmacological activity. But depending upon the different substituents, different structures are changing. And whenever any substituent is changing, their pharmacological activity is also changing. But in case of synthesis, if the synthesis is going on for any drug, we have to introduce a new substituent by the synthesis process. Then again, we have to take the activity through different animal study. So that will be time consuming and that will be so much laborious work and you cannot predict the activity that whether the drug has been synthesized or actually synthesized or no. So there is a software invention that is known as the quantitative structure activity relationship that describes with the software if we introduce any substituents like ethyl group, or nitrogen, sulfur, whatever you want. If you want to introduce any substituents to any group or remove any substituents from any group or any compound, so there will be some structural, there will be some physiological parameters changes like their solubility changing, their toxicity will be increasing, their bioavailability will increasing like this. So that will be determined by the software. That is known as the QSR or the quantitative structure relationship. So if we go for the So in case of quantitative structure relationship, so if we change the structure of any compound with the software, we can know their pharmacological property, their physiological property, their bioavailability, their solubility, their toxicity, that everything can be predicted. So that can be used for the QSR and that if the drug is showing actual activity and the toxicity is less and the side effects are less, then we can synthesize the drug in the lab. So that will be cost effective and less consumed. Okay. Next, going to the slides. So introduction, that is again I'm just I have already explained. QSR involves the derivation of the mathematical formula which relates the biological activities of a group of compounds to their measurable physiochemical parameters. These parameters have major influence on the drug's activity. So QSR derived question take the general form. So biological activity that is depending on some different functions or different parameters. So here activity is represented as the log 1 by C. So C is the minimum concentration required to cause a different biological response. Suppose paracetamol that should have the 650 mg of the concentration. If 650 mg concentration is not present in a paracetamol, they will not reduce the fever or anything like this. Okay. Next, I'm going to the parameters. So the parameters is the measure of the potential contribution of its groups to a particular property of the parent structure. So various parameters used in QSR are lipophilic parameters, that is known as the partition coefficient or pi substitutes and constituent. Then polarizability parameters like the molar reflectivity, paracord, these are the different polarizable parameters. Electronic parameter, that is the Hammett constant, dipole moment. Then some steric parameters are there, that is the Tafts parameter. Then miscellaneous parameters, molecular weight, geometric parameters, these are the different parameters. Okay. Now we will be discussing one by one. So in case of lipophilicity is a partitioning of the compound between an aqueous and non-aqueous phase. That means whether the drug will be soluble in the liquid phase or in the aqueous phase or not, whether the drug will be solubilized in the blood or in the cell. So that will be dependent by some partition coefficient. Suppose P is the formula that is the partition coefficient. So drug in octanol divided by drug in proton. So the drug will be soluble in either octanol or proton. So typically over a small range of log is 1 to 4, that is the straight line is obtained. Here log 1C, that is the concentration will be defining as the 0.75 log P plus 2.30. If the graph is extended to very high log values, then get a parabolic. So if p is small, dominated by the log beta. When p is large, log square dominates, so activity decreases. So you can see the graphical representation here. Now, coming to the high substituent constant or hydrophobic substituent constant. So any drug which will be hydrophobic, so they may lose the solubility. Next, the high substituent constant defined by the hands and co-workers by the following equation, that is a px equals to log px minus log. So a positive pi value indicates that the high substitution has a higher liquidity than the hydrogen and the drug favors the organic phase. That means if the drug having the positive pi value, so that will be having the higher solubility than the hydrogen. That will be not first soluble. So if any drug have to be highly soluble in the lipid medium, then the pi value should be increased. Then the solubility will be more in case of blood or in the plasma, the same. And the drug will favor the organic phase. That means more the drug is typically, more the drug is soluble in the organic phase. Negative value means that the pi substituent has a lower toxicity than the hydrogen drug process. That means if the pi substituent has the negative phase, then the drug will go aggressive. So depending upon the criteria, whenever we require the drug should be solubilized in the aqueous or lipid, that should be used. Suppose any drug like injection, that should be solubilized in the water. So that's why the drug should be aqueous soluble. Okay. Now there are some electronic parameters like the Hammett constant that is represented by the sigma, and the formula is Sx equals to log, that is Kx by K benzoic. That means the partition coefficient in the benzoic acid that is depending, and Kx is the unknown electronic parameters. So here electron join groups, electronic equilibrium shifted to the right side. That means whenever the drug will be dissociation, there will be some left side and right side dissociation parameters. So the equilibrium shifts to right towards the benzoic acid. That means that will be dissociated more, since Sx, log x and minus log K benzoic acid. So if the S will be positive, then Hammett constant takes into account both resonance and inductivity. Thus, the value depends on whether the substituent is para or meta substituent. That means Hammett constituents will derive the drug, whether the drug will be para substituent or meta substituent. Suppose any drug, it's a pitch or any nitrogen. If the drug is having Hammett constituents higher value, so the nitrobenzene or the toluene will be beta-directing or para-directing. As a result, they will having the good effect. But if it is orthodirecting, there will be so much, there will be more at such stage effects. So that the drug may not be active. You know the enantiomer of the drug, some of the enantiomer is, some of the enantiomer is required. So that depends on the this Hammett constant. Next, steric substituent constant is a measure of the bulkiness of the substance and effects on the closeness of the contact between the drug and the substance. So that means if the drugs having the bulky substituents, then it will be problematic. So the drug will not be binding to the receptor site. Next, Taft-Sperry factor, that is a TS, that was discovered in 1996. That is an experimental value based on the rate constant. Then molar rate. That is the molar reactivity. Molar reactivity measure the volume by an atom and a group. Equation includes MW density and the index of refraction. That means the drug will be optically active or not. When looking at the optical activity, the drug will be biologically active. Now there are another parameter, that is the Barlow steric parameter, that is also a computer program based on the dactyls, gradients, and bond lengths of the drug. That can be also defined by this parameter. Now there are some methods, that is known as the topless method, that is not frequent. Now going to the computer-aided drug design. So through this QSR, we can design the drug through the computer-aided program. Okay. So, going to discussion. Computer are an essential tool in the modern medicinal chemistry and are important in both drug discovery and development. So, coming to the molecular model. What is molecular modeling? So, molecular modeling is a general term that covers a wide range of molecular mechanics and computational chemistry techniques used to build, display, and manipulate and stimulate and analyze molecular structure and calculate properties of this structure. That means molecular modeling. Through this molecular modeling, we can increase the drugs um, activity. Okay, so through this molecular modeling, first we can draw the structure, then build the structure, then display, then manipulate the structural features, then stimulate the structure, and finally we can analyze the molecular structure, and their properties can be calculated. Molecular technique can be divided into molecular graphics and computational chemistry. So this drug will have been the graphics and computational chemistry can be divided, and they will be doing some drug formation. So through graphical model, this drug can be synthesized. And molecular mechanics, that is also some parameters are added. In this technique, the energy of the structure is calculated. The equation used in molecular mechanics follow the law of classical physics applied to molecular nuclear without consideration of the okay. So here we can use the total potential energy in a molecule is given by the sum of all energies of the different and repulsive forces between the atom structure. So E total equals to E stretching, summation summation of the bending, summation of the torsion, and summation of the equivalent. So it is the very good software, and through this method we can get the advantages like the less time consuming and simple it is too simple, and the drug can be synthesized through this parameter. Now coming to the molecular dynamics. So molecular dynamic programs allow the modular to show the dynamic nature of the molecule by stimulating the natural motion of the structure. The velocities of the atom are related directly to the temperature. Higher temperature stimulation are used for the searching the composition shape. Molecular dynamics can also be used to find structure and conformation analysis. So conformation analysis in Buchan can be different. So if the composition of the drug is changing, the activity will change. Next, coming to the quantum mechanics. So here, so parameters are like heat of formation, dipole, electrostatic potential, conditions, tension, that are used. So thank you. After this, you have to study. Thank you all.